Hi there, I'm going to be talking today about parallel lines. We're going to give a brief introduction to some of the rules that we use with parallel lines, as well as some of the terms that we have. So some of you may have heard of the term parallel lines before, and it simply means two lines that never cross. If we have equations, then the slopes of the equations are the same, but as you've noticed, we've not really been using many numbers, so we just know that their two lines never cross. Our other term here is transversal. And a transversal is simply a line that cuts across two parallel lines, so it intersects both of the parallel lines. And as you can see, well, as I'm going to show you, we've got some rules when a transversal cuts through two parallel lines. So right here I've got a diagram, and I have two lines. The first line goes through AB, so I'm going to call that AB, and the second one is CD, so that's CD right here. When I have arrows here and here, like this, it means that these two lines are parallel. So any lines that have the same number of arrows like that, it means they're parallel. If a pair of lines have two arrows, it means those are parallel. If a pair of lines have one set of arrows, then those lines are parallel. Well, and so we would write this out as given because it's shown to us in the diagram. It's shown because of those arrows right there. And we would say AB is parallel to CD. So this symbol right here means parallel. So if you see two vertical lines like that, it means that the two lines that we have are parallel to each other. And when we're given two parallel lines, and the parallel lines are cut by a transversal, and so this line that's diagonal here is called the transversal because it cuts through both of the two parallel lines. We have a couple of different rules we can use. The first rule is called alternate interior angles. And what this means is that angles that are on the inside of the two parallel lines, so the two parallel lines are here and here, the angles that are on the inside here and on opposite sides of the transversal. So for instance, number 3, the angle that's at 3 and the angle that's at 6, both of these are congruent. Also, the angle that's at 5 and the angle that's in 4 are also congruent. So I would say by alternate interior angles, angle 3 is congruent to angle 6. And angle 4 is congruent to angle 5. Now, as you know, most of the times we've been working with angles, we use the 3 letters to talk about it. And for most of the problems, we will be. But obviously, I'm kind of limited on space here, and so I'm just using numbers for the moment. But most of the problems, we will still be using the 3 letters as we have been doing for angles. The alternate exterior angle rule is very similar, but instead of talking about the angles that are on the inside of the two parallel lines, we're now talking about the two angles, or the two sets of angles that are on the outside of the parallel lines. And once again, the alternate means they're on alternate sides of the transversal, and they're on the outsides. So for instance, number 2 and number 7 are congruent, and then number 1 and number 8 are also congruent. So we say 2 is congruent to 7 because they are on the outside of the parallel lines and they are also on opposite or alternate sides of the transversal here. And we also have number 1 and number 8. So the angle at 1 and the angle at 8 are also congruent. So the angle at 1 and the angle at 8 are congruent by alternate exterior angles. The last rule we have here is corresponding angles, and corresponding angles basically means they're in the same position at the two different intersections. So for instance, 1 and 5 are corresponding angles because they're both in the upper left corner. 2 and 6 are corresponding, 4 corresponding, and then 3 and 7 are corresponding. So there's 4 things that we can get here from this one rule. So we've got angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and then lastly, angle 4 is congruent to angle 8. So we've got 3 different rules with the parallel lines here, and we'll be able to use these for several different types of problems, including some more triangle problems. So stay tuned for more videos, and we'll do some example problems with these as well.